Hi, everybody. I'm Joey, and we are a Code Plus team focusing on data visualization in Python. I'm going to let my team members introduce themselves, starting with Alan.
Hi, everyone. I'm Alan.
I'm Melissa.
I'm Juan.
And I'm Susan.
One of the key benefits of modern technology is that researchers have access to millions of lines of data on a variety of topics. This comes with a problem, though. Datasets this large are difficult to visualize. It requires a lot more than copying and pasting them into an Excel document and pressing display graph. We've been tasked with solving this problem for two Duke researchers. Our solution involves using state-of-the-art visualization tools to visualize our researchers' datasets. Our visualizations are helping them understand their data more completely and come to conclusions that would otherwise be difficult to find. Our researchers are experts in their respective fields, but creating these visualizations themselves would involve learning new, pretty complex tools. So that's where we come in. I'm going to let Alyssa introduce our first researcher, Celine Robinson.
So our first researcher, Celine Robinson, is a fourth-year PhD candidate here at Duke, specifically interested in studying systems, risk, and decision. And she's provided us with two pretty large data sets. So the first one is the above-ground storage tank data set. This one has 98,000 rows. All these observations are about petrochemical storage tanks across the US. And then in addition to that, we also have the Info USA dataset. So this dataset includes household level census data for households all across the US. So this one has around 192 million observations across 38,000 files. And what Celine wants us to do is relate these two datasets to see the risk of a petrochemical tank spilling and the impact that it can have on the communities around it. I'll let Juan introduce our second researcher.
Thanks, Alyssa. The other researcher is called William Myerson. He is a Yale graduate studying to become a physician scientist. In fact, he's currently a psychiatry resident at the Duke Medical Center. He's interested in measuring the effect of social media on mental health. In particular, he's assessing the correlation between people posting close to their bedtimes and sleep disorders, and whether this affects mental health. He's looking at large sets of data extracted from the Reddit API, personal research, and other researchers. All of these data sets combined add up to a total of over 236 million observations. As you can imagine, producing useful visualizations with these large data sets requires the integration of a series of tools which my teammate Susan will explain in further detail.
Thanks, Juan. So for our tools, first we're using Jupyter Notebook, and this helps us import a variety of Python libraries and makes it really easy to run individual code chunks. We're also using Views, which helps us handle data analysis with the large data sets we just talked about. Also, we're using Dask, which helps us with multiprocessing and parallelism. And lastly, we're also using Data Shader, which helps us avoid overplotting, especially when working with hundreds of millions of data points. And now I'd like to pass it on to Alyssa to show some demos.
Yeah, so here's a sneak peek into how we process our data in order to make meaningful visualizations. So here we use machine learning in order to calculate the shortest distance between each household and the tank nearest to it. So the first thing we do is we import all our libraries and packages, and then we read in our Info USA data. So that's our household data. And then we use Dask, our multi-processing library, in order to transform this pandas data frame into a way that we can use it later. Dask is really important because we're working with around 53 million observations, and without it, it just takes too long and it won't run at all. Next, we read in our AST data, and then here is how we find the closest tank to each household. Doing the brute force method with this amount of data is just not feasible, so we use a neighbors module from the sklearn library, in particular the ball tree function. And this ball tree function basically uses machine learning in order to identify the tanks nearest to each household. And so it'll output each tank and the coordinates of that tank. And then we can use this information along with the coordinates for each household to calculate the distance between these 2 points. So our outputted data frame has all our demographic data with the coordinates for each household, all our natural hazard risk data, and then the distance from that household to the petrochemical tank nearest to it. And so when we export this data frame as a Parquet file, we can use it in the visualizations we're going to show you next. So here is a visualization we used using the data frame that we just processed. And so here we're plotting the number of households near a tank per county in the US. This one we made using the Geo Views library, and it plots all the counties in the US colored by the number of households within 5 miles from a storage tank. And so the ones in gray have 0 households within that distance category. And so if you hover over each county, it will tell you the county name and then the households within certain distance categories of a petrochemical tank as stipulated by a researcher. Zoom in and zoom out. This is just so that Celine can identify areas that maybe she would like to focus on. I'll let Susan show you a cooler visualization that we made using the cross filter library.
Yeah, so these next two visualizations are showing case studies, so Harris County and Charleston County, and the households in those counties and their proximity to tanks. So since we use GPUs to make them, you can zoom in and out on the households, and then also multi-select for households 1 football field away, 1 mile away, and 5 kilometers away from a tank. And you can also see the households with the tank on the multi-select. Additionally, we have multi-selects for elderly and not elderly, and households with and without children. And lastly, we have a distance range slider feature, so you can look at households a specific distance range away from a tank. And next, we have a very similar visualization, except for all the households in the US. And once again, you can zoom in and out to look more in detail at the households. And then on the side, we have multi-selects for households with elderly and without elderly. And in this one, we're also looking at natural disaster risk indexes. And so in particular, we're looking at coastal flooding risk. And so with this slider, you can see that coasts in Florida and Washington have highest risks for flooding. And once again, we also have the distance range slider as well. And now I would like to pass it off to Joey, who's going to show a really cool web app demo.
Yeah, thanks, Susan. So right now you might be saying, this is super interesting, but how am I affected? How do I know if I need to worry about a petrochemical tank breaking near me? To answer this question, we've created a website that allows a user to enter any address throughout the United States and get their risk of exposure to a petrochemical tank leak. Here's what it looks like. To calculate the risk of exposure for any point in the United States, we've compiled millions of lines of natural hazard data to find the likelihood that each individual petrochemical tank breaks. We then consider how close is the point that you entered to the nearest petrochemical tanks and how secure are those petrochemical tanks. The first address I'm searching up, 140 Science Drive, is where we are now, Grosse Hall, North Carolina. You can see that the nearest petrochemical tanks to our location are pretty far away, almost 20 kilometers. This results in a really low risk index. You also see this map, which has a couple features I want to go over. The address is in blue. When you hover over it, it shows you the address that you entered and the calculated risk index. In this case, the tanks are in green because they're far away. When you hover over them, you get the tank type, the coordinates of those tanks, the distance from the address, and most importantly, the calculated risk of that tank breaking. Now I'm looking up Charleston, South Carolina. This is one of the hot spots that Celine identified as an area that she wanted to learn about. Here you can see that the tanks are a lot closer, which results in a higher risk index of 5. Now the tanks display as red, and again, if you hover over them, you get the calculated risk that those tanks are going to break. Next, I'm going to pass it over to Alan, who's going to go over the first visualization for William Myerson.
Thank you, Joey. So this first demo that we have is an interactive stacked bar chart, and this displays the relative frequencies of posts by hour of day for each of the 30 subreddit clusters in our dataset. So as you can see, the interactive hover feature displays the exact breakdown of relative frequencies for posts by each hour of the day. And you can view this for all 30 subreddit clusters. And our next visualization is a geographical visualization of our subreddit demographics data. So this is an affluence bubble map that displays the affluence of Reddit users around the world by subreddit. So the way to interpret this is the bigger the bubbles, the higher the affluence. So comparing these two subreddit clusters specifically, you can see that the gaming one subreddit cluster on average has higher bubbles, indicating that the users of this subreddit cluster have higher affluence. And there are some tools on the right that you can use to zoom in or select a smaller subsection of the map to view the points at a much smaller and closer scale. As you can see, there's a hover feature that shows you the points in detail. And to show you some of the code that we use, so we first read in a pre-processed data set where we merged some data sets together. And then we drop duplicates to make sure that the visualization would load properly and to prevent overplotting as well. And as you can see in the last two code chunks, we use some code to customize this bubble map. So the third code chunk displays the key that we use for the helper tool. And then the bottom code chunk shows some of the customizations that we did to create this bubble map. So it's just the transparency of the points and the color of the points as well. And now I'm going to pass it over to Juan to show you some of our other demos.
Thank you, Alan. This visualization, as the title very accurately describes, shows Reddit post activity around the world by hour of day and day of week. To your top left, you'll see that there are 222 million points plotted, but as we select specific hours of day, this turns to about 10 to 9 million. This is because we're seeing the posts across the world that were done in that specific time frame. We can also select a specific day of the week with our other drop-down menu and go more in detail by selecting a specific hour during that time of the week. You can see in your top left that the number of points being shown is reduced. Now, in our next demo, you will see a choropleth map that shows subreddit relative post frequency per state. In this map, the darker the color with which the state is shown, the higher the post frequency. As you can see, we do also have a hover tool in which you can see the state abbreviation and the post frequency in terms of how often that state appeared in our data set. You can hover over the tools as well as zoom in to the states to see the information in more detail. And we do also have a reset button in case you want to go back to its original format. Now, I would love to pass it over to Susan, who will go over some of Celine's group challenges.
Thanks, Juan. So for challenges for Celine's group, in the beginning, we were given around 38,000 InfoUSA files. And so each of those files represented one zip code in the US. And so in order for us to be able to make county level and country level visualizations, we needed to merge all those together. And so eventually we were able to do so using pi arrows at the Parquet file format, which made reading in the files and merging them a lot faster. Another challenge we encountered was for each of the files, we had a lot of columns, a lot of variables. So we definitely did a bit of work to clean and process that data up. And lastly, as you saw in a lot of our visualizations, they centered around distance between households and tanks. And so in order for us to be able to calculate the distances between each household in the US and find each household's nearest tank, we were eventually able to do so using the machine learning sklearn method that we mentioned earlier.
In terms of William's group, we did find that figuring out how to combine the different data sets was a bit complicated. However, we were able to figure this out by using common columns between the data sets and saving the files as Parquet. This allowed us to load them faster when we wanted to use them for our visualizations. We did also encounter some limitations with the Python 3 kernel when we wanted to create visualizations with large data sets. However, once we started to master the CU cross filter library, we started using GPUs and were able to successfully visualize the data. And finally, we did also have some trouble converting Unix UTC time into readable time and adjusting this to time zone, but using the datetime library in Python, we were able to do so successfully. Now I'd love to pass it over to Alan, who will go over some of our final deliverables.
Thank you, Juan. So for this project, our culminating final products are 2 fully documented and reproducible GitLab repositories for each subteam. So the general GitLab repository has been prepared for any Duke researcher that wants to use our code on the Duke compute cluster. And because we've signed agreements for some of the demographic and census data to make sure that we don't publish the entirety of these data sets until they're ready to be published, we've created synthetic data to demo our code for the general repository specifically. And this will be accessible, like I said earlier, to any Duke researcher that wants to use our code. And then the researcher-specific GitLab repositories have been prepared for Celine and Will, our researchers, and this uses the actual data. So as you can see, these animations show a little bit of what the front page of our GitLab repositories look like. And if you're interested, we have the QR codes for the general GitLab repositories in case you want to check those out. And now I'll hand it over to Alyssa to wrap up our presentation.
Yeah, so we just wanted to end our presentation with a big thank you to Oracle. They are our corporate sponsors and have been super helpful throughout these past 10 weeks. They have allowed us to access a generous amount of credits on the Oracle Cloud. And so we're able to run our code on their cloud, which is super cool, has allowed us to expand our work and host the website and web app that Joey demoed earlier. And then in addition, a big thank you to all the Code Plus team and our project team leads. So with that, we'd like to open the floor up to any questions.